All right, ionic compounds. Binary ionic compounds with monatomic ions. Let's get this done. Now I want to give a shout out. I want to start this video by giving a shout out. You know what? Give a shout out to all you students out there that aren't in the haven't formally started chemistry yet, but a lot of you are taking the initiative to move ahead on your own while we're doing our PSSA review. It's great that I see a lot of you taking initiative, taking the challenging packets, working through it, coming to chemistry help desk when you don't have to yet, and working hard. And you know what? That's outstanding. Keep up the great work. You know, love it. I love the fact that people are working hard, taking initiative. We'll see more people do that. Okay? It's outstanding. I mean, I have people coming into the SSS asking me questions. You know, when we're just doing PSSA review, I have kids asking me questions about electron configurations. We haven't even taught it yet, but guess what? I guess you seem to understand it through this on-demand thing. Keep it up. Spread the word. This is outstanding. Love to see the initiative being taken. I mean, I think it was one of the high school principals came over here and said, you know, when you go to the high school, you're either going to be one of those people that stands around and waits for things to happen, or you're going to make it happen. Okay? And a lot of you are starting to make it happen in terms of taking that initiative, trying to be the best. Okay? You're taking advantage of an opportunity. Okay? That's expected now. That is outstanding. I mean, I'm going to give you credit, but keep it up. It will pay off down the road. It'll pay off this year too. So when we start chemistry pretty soon, you're already going to know most of this material. Okay? So outstanding effort to you. Outstanding effort to those that are in the chemistry right now that are working hard. You know, I like to see everybody working hard, but most people aren't. It's really neat to see the fact that we've covered so much material in a short amount of time, covering things we've never covered before. It's outstanding. But shout out to you people. Periods 4 and 6, outstanding work, taking initiative. It's great. Let's see more people. Again, you people are making it happen. You're not waiting for it to happen, you're making it happen. It's a good mindset to take into that high school over there. Make it happen. Take initiative. Take risks. Take on a challenge. Pays off down the road. Don't be afraid to take on a challenge. I mean, seriously. I mean, sometimes the thing that I've taught this year is for the first time a high school level thing I've taught. We're trying new things. It's okay to try new things. It's okay to take risks. It's all right to try new challenges. Okay, you never know what will happen. A lot of great things happen more often than not. Okay? It's a good thing. Step it up and make it happen. Keep it up. All right, here we go. Start off with lithium and iodine. So let's break this down. And I have my periodic table over there. I'm going to keep pointing over there. So anybody watching me in Saudi Arabia or any other country, Canada, wherever, right? You see me pointing over that way? There's a real large periodic table over there if you've never seen this classroom before. Real periodic table. So that's why I keep pointing over there. So, you know, you'll notice after the video. Okay. We got lithium. Oops. And iodine. Okay. So lithium, here's what you need to know. Lithium and iodine. Lithium is a metal. It's on the left side of the periodic table. Iodine is a non-metal. It's on the right side of the periodic table. Okay. Now, let's break down some information so we know how to formulate this compound and draw it out. Lithium is an alkali metal. It's got one valence electron. What does it want to do to become stable? Lose one to get a full outer shell. Iodine, God bless you, Miss Camilleri. Iodine is a halogen. Why do I say that like that? Halogen. Nuts. Psycho. Freak. So you can call me a halogen sometimes. Halogen. Very reactive, excuse me. Very unstable. They have 7 valence electrons, and all they need is one more to become stable. So they need to gain 1 valence electron to become stable. And for those of you that haven't started chemistry, valence electrons, the electrons on the outermost level, outermost shell, they're the ones that are involved in chemical reactions. Okay, so here we go. So let's write out the symbol. Get some here. Li, and I'm going to put a dot right there to show 1 valence electron. It's your Lewis structure showing 1 valence electron. Let's get this thing out of here. Iodine, halogen, nuts. has 7. 1 away from becoming stable. Here's your capital Iodine at Texas Roadhouse. Love Texas Roadhouse. Hey Texas Roadhouse, if you're watching this, I just gave you a free advertisement. I'll take any free gift cards you have. Appreciate it. Always go there. 1, 2, 3, 4, 5, 6, 7. Okay, now check it out. I drew X's here just so you can see the difference. They're valence electrons, but I just wanted you to see what happens to this when it gets over there. Okay? They're valence electrons, whatever, doesn't matter. Okay, so lithium sees iodine. Lithium wants to lose 1, iodine wants to gain 1. Okay, so watch this. Here it goes. Over here, put the dot right there, because that came from lithium. Kind of erase this a bit. So right now at this moment, lithium atom has transferred its valence electron, TRVE, transfer valence electron, to form an ionic bond. An ionic bond between a metal and non-metal. Now, that electron went over there. What happens to the charge of lithium? The charge becomes +1. So now lithium is now an ion. We don't change its name. The metal doesn't change its name. So it's lithium +1. That is a cation because it's positively charged ion. Over here, iodine just gained a valence electron. So it gained 1 more negative thing, right? While the number of protons stays the same. Nuclear charge stays the same. So anyway, this gained a valence electron. This now has a -1 charge. Okay? So this has a full outer shell. This has a full outer shell. Their charges are equally opposite. You have a metal, which is a cation, a non-metal, which is an anion, A-N-I-O-N, a negative ion. Okay? So we transfer it over there. There's your ionic bond. So now here's your formula, Li-I. And we call that, we don't call it lithium iodine. Well, that just tells me I've got atoms of lithium and atoms of iodine. How do I differentiate or give this compound a specific name or give it specificity? Watch this, we name it lithium iodide, I-D-E ending, lithium iodide, okay? So that's how that works. So you want to show me family or group, number of valence electrons, and again in a group or family, we are family, hey, I got all my valence with me, same number of valence electrons, because they react the same way. Oh, forgot about helium. Helium's a noble gas. Remember helium? Has 2. Why? Think back, review. Why is helium part of the noble gases with just 2 and the rest have 8? You should know that answer. But I'm not saying you know what the answer is. That's why we laugh like that, because helium is a little bit strange, but still part of the noble gases. Stable. Okay, so here you go. Questions on that? I know there's nobody in this room. Write them down. Here we go. I'm going to erase it. It's my eraser. It's a wonderful day here at the Springford 8th Grade Center. You know, I got to tell you, you know what, Mr. Siggins, if you're watching this, you do an outstanding job, Mr. Siggins. Mr. Siggins, you're my hero. You know, Mr. Siggins, I'm going to sing to you. Did you ever know that you're my hero? I can fly higher than an eagle. You are the wind beneath my wings. There you go. Shout out to you also, Mr. Siggins. You are the man, Mr. Siggins. All right, here we go. I hope you're watching this. I really do. You'll love that I just did that. All right, here we go. Go to potassium and oxygen. Here we go. Let me get some coffee here. All right. Potassium and oxygen. Okay. First thing you got to identify, metal, non-metal. And I keep doing, I mean, obviously all these are going to be metals and non-metals, but when we move on through the chapter and we get to covalent/molecular compounds, it's going to be 2 or more non-metals. So when I give you an exam and I mix all these different compounds between covalent compounds, you have to know how to draw them a certain way through a covalent bond. And I got ionic compounds where you have to show the transfer. How do you differentiate between the two? That's why I implore you to write above what these substances are so you know what you need to do. So if you see metal, non-metal, you're going to go by the way of an ionic compound. And you're going to show the arrow, you're going to draw it through. If you see 2 or more non-metals, you're going to show covalent bonds. Okay? We'll get to that later down the road, but get in the habit of identifying metal, non-metal. It will make your life easier on an exam where everything's all mixed. And you've got to differentiate real quick. in a quick amount of time, okay? And I know they're all metal, non-metal. Get in that habit now, it pays off. Okay, potassium, K+, it's an alkali metal. Group 1, 1 valence electron. Oxygen, it's part of the oxygen family. It's group 16, 6 valence electrons. This guy here wants to lose 1. Oxygen wants to gain 2. Okay, so here's your metal and non-metal. Most reactive set of metals. Alkali metals wants to lose 1 there to get full outer shell. Oxygen family, non-metal. Second most reactive set of non-metals. Right next to that. Hello, oxygen family. They need to gain 2. Okay, so let's take a look here. So we have our information, now we're ready to draw it out. So let's put it over here. Here's K. Oh, right there. 1 valence electron. Here's oxygen. I'll use the X's again. Again, they're valence electrons. 2, 3, 4, 5, 6. Okay? So now potassium needs to lose 1. Oxygen needs to gain 2. So potassium, to become stable, gives oxygen 1 of its valence electrons. And I'll put the dot there to show you that. So now this potassium right here is now stable. It's got a positive 1 charge. It's got a full outer shell. But oxygen, on the other hand, only has a charge of -1. Because it needs 1 more valence electron. It's not like happy yet. It doesn't have a full outer shell. So we bring in another potassium to get equal opposite charges. Because notice, oxygen here, the ion oxide has a -2 charge. Potassium has a positive 1 charge. You need to get equal opposite charges to get stability. Okay? You need to get equal opposite charges. So it's going to take 2 potassiums, because look here, +1, and I don't know if you can see this down here, gives you a +2. Here gives you a -2, one of these oxygens. So it takes 2 potassiums to stabilize 1 oxygen. So we're going to bring in another potassium here with a positive 1 charge eventually, because we're going to transfer that valence electron. Here's its valence electron. Here it goes. Whoop, there we go, out of here. Now, so I've got here 2 potassiums, 1 oxygen. Each potassium ion, cation, has a positive 1 charge. This oxygen atom that gained 2 valence electrons through the transfer of the with the ionic bond, metal non-metal, is now at a -2 charge because it gained 2 valence electrons while maintaining the same number of protons. So the formula for this is going to be K2O. Okay, well how do I name K2O? How do I differentiate between potassium and oxygen atoms? Well, we differentiate it by calling this potassium oxygen? Oxide. Potassium oxide. Okay? We differentiate it to potassium oxide. Alright? Very simple. Okay? Write down any questions that you may have. Let's do beryllium and oxygen. That's an interesting one. And I don't have the paper in front of me. I think it's on the first page. Beryllium and oxygen. Beryllium and oxygen. Okay. Get my technology here. Okay. Here's beryllium. Now look here. Beryllium. For those of you that have difficulty spelling elements, beryllium. Beryllium. It's really beryllium. But if you have to say it beryllium, I don't care. Spell it correctly. Beryllium. So, for you people that know about the elementary school, is this like foundations? Phonics? Right? You have to tap it out. How do you do it? I don't know. Beryllium. 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 I don't know. Mike, I don't know how that works. But anyway, well, we just had to spell words back in the day. But let me try it again. Foundations. Here we go. Beryllium. Boom. And then go across. Beryllium. There we go. And what's the other? Oh, oxygen. Look at this. I'm trying to do an elementary lesson. Could you imagine me teaching elementary kids like tapping like the foundations? You know what I mean? I don't think that's a trick word. I think they're called trick words or something. Who knows? But could you imagine that? Hey, little kid! Tap out beryllium now! Be funny. Okay, here we go. Beryllium. Beryllium. So some of you might want to look up foundations and start, have difficulty spelling these words. Maybe tap them out. I don't know, tap out, I guess they're the syllables, who knows. That's why I stick to science. Here we go. Beryllium. B-E. It is a alkaline earth. 2 words, alkaline earth. Alkaline earth, metal. Alkaline earth, not alkali, 1 word. Alkaline earth, 2 words. 2 valence electrons. Here those 2 dots right there. Okay. Beryllium and oxygen. Oxygen family group 16. Here's oxygen. Now, so again, this is an alkaline earth metal, right? 2 valence electrons, wants to lose 2. Oxygen, part of the oxygen family, gain 2. Okay, now, look here. Here we go. Okay. Oh, did I just write? Here. 3, 4, 5, 6. Didn't finish that. Okay. 6 valence electrons. Here we go. All right. Beryllium comes in, wants to give 2 valence electrons when it becomes stable. Oxygen has 6, wants to gain 2 to become stable. Here we go. 1. Oop, now it's positively charged. This is negatively charged. But they still have 1 to get rid of. They still have 1 to get rid of, and this one to gain. This one needs to gain 1. Lose 1, gain 1. Lose 1, gain 1. Still. Here we go. Bring it over. Positive 2, negative 2. So now they're equally opposite. Now take a look here. This lost 2, that gained 2. Stick them together, you've got B-E-O, beryllium and oxygen. Well, how do you name it? Write it down. Take a second, write it down. Look at the trend. To differentiate, to give the compound specificity, we don't call it beryllium oxygen. We call it beryllium oxide. There you go. Beryllium oxide, okay? And that's an ionic compound formed through ionic bonds through the transfer of valence electrons between a metal and not metal. Drop my chalk. Okay, good. And I'll do one more for you. Okay? Got it? And it's on the 2nd page, I think. Let's just do magnesium and phosphorus. Let's tap foundations. Magnesium. I think I did it right. Who knows? Phosphorus. Right? There we go. Any of you have siblings that know how to do this? I'll take suggestions. Here we go. Magnesium. You can tell I don't help my kid with foundations homework. Alright. I'll do the math. Here we go. Magnesium is a metal. Phosphorus is a non-metal. Here we go. Magnesium. Alkaline earth metal. Right? Group 2. 2 valence electrons. Lose 2. 2 plus. Phosphorus. It's in the group 15. Has 5 valence electrons. Gain 3. That's a 3, believe it or not. There you go. So look here. Okay? So, now we've talked about this in class, where you can crisscross and drop. Okay? We'll do that in class. It is a quick, easy method, but you still have to do all the other work. Okay? I don't recommend you exclusively do that unless you're polyatomic ions at this level. Because if you remember with beryllium and oxygen, if you crisscross and drop, right, you get Be2O2, and that is incorrect. Kids forget to look up here, and they see, oh, they're equally opposite, they cancel out. You stick it together. Okay? Again, if you want to crisscross and drop to start, and then build your compound from there, that is fine. You can do that here, but here's what I like instead. Mg has a positive 2 charge. This has a negative 3 charge. How can I get these two to have the same, I guess, common factor, same multiple, whatever you want to call it? This is a large number. What do 2 and 3 have in common? 6. So make this a negative 6. How do I get to negative 6 from here? If I add another P, negative 3, give me negative 6. Well, how do I get positive 6 to get equal opposite? You need equal opposite. I need another magnesium, 2 plus, and I need another magnesium, 2 plus. 2 plus, 2 plus, 2 plus gives me plus 6. Equal opposite. You do it this way, you can't go wrong. This is what, I'm sure that's what they're going to expect in high school. And you can do crisscross the easy way. I would know it this way. I really would. 2, 4, 6, equal opposite. So I'm going to need 3 magnesiums, 2 phosphoruses, ions, to achieve stability. Okay, easy. We can do that. So let's draw it out. We'll talk it through when we're done. Magnesium has 1, 2 valence electrons. Phosphorus has 1, we'll use the X2, 3, 4, 5. Magnesium wants to lose 2, phosphorus wants to gain 3. Here's my formula. So I know I'm going to need to do some work here. Show the transfer of the valence electron up here. 1, 2. Erase them a little bit. This magnesium now has a positive 2 charge, it's an ion. This phosphorus now has a negative 2 charge, but it still needs one more. There's still a spot right here for a valence electron. So they're now ions, but this is not stable yet. So we bring it, this one's happy, this one's stable, full outer shell. Bring in another magnesium. 1, 2 valence electrons. Transfer this over here, right? Now this phosphorus is now happy. It's got a negative 3 charge. It's got a negative 3 charge. But this magnesium is not too happy right now because it still has 1 valence electron. It's still unstable. So what do? Bring another phosphorus. 1, 2, 3, 4, 5. Gain 3, lose 2. Well, here we go. Well, this guy needs to lose 1 now. Check it out. Right here. There you go. Get rid of that. Erase that up a little bit. This magnesium is now positive 2 charge. This phosphorus is now charged with a negative 1 because it's got 1 for magnesium. Okay? So now this is now satisfied, happy or whatever, right? Stable. Oops, dropped my technology. Hold on. Very costly. Here we go. So we bring in another magnesium. 1, 2. Hey, what is up with me in the chalk today? Keep dropping. Okay. Watch this. Bring 1 there. Bring 1 there. So now I've got 3 magnesium ions with a positive 2 charge, stable, fulfilling the octet rule, full outer shell. Here I've got 1 phosphorus ion, which is now phosphide, to differentiate, stable, gain 3 valence electrons. Ooh, I didn't draw that one in, sorry, right there. Here's a stable one, here's another stable one. So I have 2 phosphide ions with a total net overall charge of negative 6 between the 2 of them. Here this is positive 6, they're equally opposite. So now you're given the formula Mg, as we wrote up here. Where is it up there? 3P2. What do we call it? Magnesium? Phosphorus? No. Phosphide. I-D-E ending. Okay? Magnesium phosphide. Alright. Get her done. Work on that page. Most of your chapter 2 packet, there's so many pages of this. Practice, practice, practice. Speed, speed, speed. Accuracy, accuracy, accuracy. Do it, do it, do it. Again, and I'm going to keep saying this, especially this chapter. You have an opportunity to work at a high level. Get your hands dirty now, work at a high level, work out the kinks, right? Learn it. When it's retaught a couple of years from now, you'll have a nice foundation of familiarity. And because of that, you'll be able to spend time on the higher level material and study more efficiently. Notice that word efficient, because some of you are still spending a lot of time on homework, and that's okay, you're learning. But you'll be able to study more efficiently on the things you'll need at the high school. Higher level topics of chemistry that I can't get into because you've got the foundation. And if you get the foundation and you're able to devote more time to higher level topics in the high school when every grade counts, unfortunately, because it's very competitive, unfortunately, you're going to come out ahead. And I hope, just hope one day, you know, you're going to come back and look at this class and say, you know what, it was brutal. It's not easy for 8th grade, but I did what he told me to do, kept the level head, worked hard, it paid off, okay? I mean, the fact that you're doing this quick, easy, you know, we're not going to spend much class time on this. We've done it. Here it is. This is going to allow us to do other things. We're going to name acids and bases for the first time ever. We've never done that before. I'm a little nervous. I've never taught it before, but we're going to do it. We'll do it. We're gonna name acids and bases. How cool is that? I can't wait to try our biochem unit at the end of the year. Never done that before. You keep working at it. Wait till you see how much it pays off a couple years down the road. All right, very good. Get to work and get her done. Let's go. Dominate the state. Again, the standard is set. You achieve it. All right. Bye.